Hello and welcome to this week's Wireless LAN News Desk. My name is Tom Carpenter. I'm the CTO here at CWNP. And this week, March 23rd, 2018, in the news, we have just a couple of items to talk about. First of all, really big news this week, and if you're not familiar with this organization, you may have missed it because you may not get emails from them and so forth. But there's an organization called the Wireless Broadband Alliance, WBA. And this last week, they introduced their implementation guidelines. So these implementation guidelines consist of two things. There is the set of documents that's the guideline document set itself, and then there's also a checklist. The checklist is publicly available to anyone, whether you're a WBA member or not. The guidelines are available only for WBA members. Now their plans are to release specific guidelines throughout the year and into the future on high density, hospitality, other types of environments, being very specific about some guidelines for those environments. But if you look at just the checklist, you can see some really interesting things. First of all, they break this guideline for Wi-Fi implementation into four basic phases: planning, site survey, implementation, and documentation. Now I'm going to go into some of the details of the first three of these phases that they provide through the checklist itself. So first of all, in planning, you start with requirements. Then you determine if it's an upgrade or a new install. Any required Wi-Fi Alliance certifications to make sure that you're acquiring hardware that is going to give you what you actually need. Capacity planning is key. Signal level targets. So in other words, instead of just saying we want coverage, what coverage do you want based on signal levels? PoE requirements for powering your APs and so on. Security needs and network segmentation. So these are considerations in the planning phase. Then when you move to site survey, it starts with customer interviews, discovering current problems. So what's wrong with the current wireless network if one exists? And what are the problems that you're trying to solve? And then obtaining key documents. These would be things like blueprints, network topology, security credentials, things like this that you might need to actually do a good security design. And then using the right survey tools like spectrum analyzers, client devices, Wi-Fi data gathering tools like Wi-Fi scanners and protocol analyzers, APs, controllers, battery packs, temporary mounting equipment, cameras, flashlights, binoculars, measuring wheels, ladders, and all of this is listed among their list of equipment that's needed for the site survey. Then deciding if it's passive or active. A passive survey is where you're just looking at the signal generated from the AP as you're moving about. Active, you're actually transmitting data so that you can see more than just signal strength, you can see throughput and so forth. And then coverage. Designing cell edges at 90% reliability is their KPI. Noise measurement, interference captures, and finally, channel occupancy. So this is all part of their best practices checklist for your site survey portion. And then they move to implementation. So they don't really differentiate between site survey and design and implementation. So many people would say site survey is looking at the site, figuring out what is there, and then design is about, now that I have that knowledge, how do I design the wireless LAN? So we don't do large-scale wireless LAN deployments these days very often with full AP on a stick kinds of surveys, where we literally are positioning the AP where we think it should go, analyzing the metrics, moving it to the next place we think it should be, analyzing the metrics, and doing that possibly 1,000 times with 1,000 APs. Instead, we measure RF in the environment, we measure wall attenuation, we make sure we understand the materials, the floor plans, the multi-floors, all of this information, and then we go back and design the network based on expertise. Then they move on to implementation. Proper AP locations. As you can see, they're calling this implementation, but we would think of it also as part of design, wouldn't we? Designing where the APs should go. Of course, at implementation, we're making sure they go where they should go, not near heavy reflective objects if possible, and also making sure that they're mounted where they need to be for power provisioning and data provisioning and so on. Directional antennas for high density, are we using those? The PoE budget, the backhaul throughput that's needed. Layer 3 boundaries, this would be your IP layer boundaries with router, ACLs, firewalls, things like that. And then VLANs, so you can think of this like a layer 2 boundary. And then we have wireless LAN profile parameters that need to be met. SSIDs, security configuration, the channel selected, things of that sort. And then capacity and coverage, have we accomplished that? Cell edge KPIs, have they been met? Their KPI is 90% reliability at the cell edge. Or in other words, the edge of where we expect people to be connecting, that they should have 90% reliability at that point. And then channel planning to minimize CCI and hidden nodes. Channel width set appropriately, so 20 megahertz and 2.4 gigahertz, and that's all. 20 or 40 in 5 gigahertz, possibly some very rare scenarios with 80 megahertz and never 160 megahertz today. Then heat maps of the implementation, RF steering, encouraging 5 gigahertz, sometimes called band steering, things like that if you choose to use it, and AP capacity analysis. So are the APs able to handle the capacity that you're actually demanding of them? As you can see, they're really looking at implementation is what they're calling it. You can think of it as all the stuff that you should have planned for in your design, and now at implementation, you're validating that your design is giving you exactly what you expect. So a common process for large-scale enterprise deployments today is do the measurements, understand the environment, get the blueprint, know what's there and what is needed to be there. Understand any interference sources that are in the space and where those interference sources are and the signals that they emanate and what signal strength they're at. So get all of that information, then you go back to your design software, Ekahau Site Survey, Tamograph, Air Magnet Survey Pro, IB Wave Wi-Fi, or possibly some other tool. So you go back to your design tool and you build out your design for these kinds of specifications that we're talking about. So everything they list as a checklist and implementation should really also be a checklist when you're designing. Then normally today we would go out and deploy that and then do a post-validation survey, probably generating heat maps of the actual results that we're getting for things like signal strength, CCI, data rates, throughput, etc. So all of that's going to be documented for our final document set. And that, of course, is the last portion of their checklist, which is documentation. So I've spent a bit of time on this because it's a good learning exercise. First of all, if you go to the WBA website, or if you just search Google for WBA implementation guidelines or something like that, you'll find the link to it. And you can download the checklist in PDF format. It's a great starting point for your wireless LAN planning and design. And it may not cover everything you need. You may disagree with some of the metrics like the 90% cell edge, but the point is it's a starting point that gets you thinking about many of the things that you do need to address when designing an effective wireless LAN. Okay, now the second thing in the news this week is a bit of humor in the news. And let me just title it, Can't Fix Wi-Fi? Give Great Support. So there was a news item released this last week where a woman was flying on Southwest Airlines, a big fan of a university basketball team because her siblings had gone to that university, and she paid the $8 to access Wi-Fi on the plane during her flight. She was going to stream the basketball game. The only problem is she couldn't stream it. So she talked to the flight attendant. The flight attendant talked to the pilot. The pilot said, hey, tweet Southwest and tell them about your problem. So she did it. Southwest responded, we're very sorry, we have to limit some application types to preserve bandwidth for all of the customers on the plane. However, the current score of the game is, and then they gave the score. So she was surprised to get the response, so she thought, why not go further? So she goes further and says, would you do me a favor and live tweet the game during my flight so I can know what's going on? So literally there was a stream of tweets. This social media person at, in this case, Southwest Airlines, watched the game and tweeted as the scores were coming in. And of course, she landed and got off the plane and was able to watch the end of the game on her phone. Sadly, her team lost by, I believe it was 5 points. But the moral of the story is if you can't give good Wi-Fi, give good support. Obviously, you want to give good Wi-Fi. This is a unique scenario. I get it. On the planes, you don't have a lot of backhaul, so you want to limit what people are doing as much as you can. So certainly in that scenario, hey, we couldn't give them the streaming video for everybody on that plane to watch the basketball game of their choice. So let's give great support at the very least. Always prefer great Wi-Fi, but when you can't do that, maybe great support will do. Okay, that's all we have in the news this week for the Wireless LAN News Desk, the week of March 23rd, 2018. Next week, we're off to the job task analyses in Las Vegas. And when that's all said and done, I'll give you an update on what that process was all about and why we do it. If you haven't already, make sure you subscribe below. Thank you very much for viewing, and I'll see you next week.